In this video, I'm going to talk about the asymptotes. Very basic lesson on asymptotes. What's the definition of asymptotes? Asymptote is a line that curve approaches more and more closely but never touch. So this statement you may have heard in Algebra 2 also, but many of you don't know how to actually find the asymptotes. It describes the behavior of the graph at its horizontal and vertical extremities. Extremities means infinity, where x goes to infinity or y goes to infinity. X and y, horizontal and vertical extremities. So before we look at the rational functions or any other functions, let's take a look at the basic functions. Which kind of functions has asymptote and which one does not have asymptote? So in your packet, you have a warm-up paper and which has a basic functions, which we look at them. So f of x equal to x, no horizontal asymptote, no vertical asymptote. In fact, all the polynomials do not have any kind of asymptotes because graph keep going forever, never level up anywhere. This is 1 over x is a rational function, and yes, always have asymptote whenever the denominator is not defined. Vertical asymptote at x equal to 0 and horizontal asymptote at y equal to 0. Let's take a look at the other group. Square root x is does not have any asymptotes. Function keep increasing forever but never level off. Okay, so then comes these two functions. E to the x have a horizontal asymptote where function levels off at y equal to 0 on the negative extremities. While ln x is inverse of exponential function, and we know that the log of 0 is never defined. That's why we have a vertical asymptote at x equal to 0. Inverse of each other. Horizontal asymptote becomes vertical asymptote. Trig function never have any asymptote. Absolute x does not have any asymptote. Cosine, sine, cosine never level off anywhere. But exponential decay function has a horizontal asymptote at y equal to 0. Again, when x get bigger and bigger and bigger, y is getting smaller and smaller and smaller, which is 0. So let's come back onto this definition of horizontal vertical asymptote. Horizontal asymptote is always line y equal to 0. As limit of x approaches positive and negative infinity. So if we are going to use the limit statement, limit x goes to infinity, f of x becomes b, which is any number. Similarly, it is possible that limit goes to the other direction, x approaches negative infinity. Function could have a horizontal asymptote at b. Okay, vertical asymptote. Vertical asymptote always occurs in the middle. Vertical asymptote, understand again, vertical asymptote always occurs in the middle. Somewhere, not at the end. This horizontal asymptote occurs at the end. Vertical asymptote occurs somewhere in the middle and x equal to a. Now the function value approaches positive or negative infinity. What that means is, I'm just giving you the example. If this is a, then there is a vertical asymptote. It's possible that the function value goes to positive infinity and it's possible that it goes to negative infinity. So this is the vertical asymptote. Vertical asymptote occurs in a rational function. Possibly one of the location is when denominator is 0. So you have to check when denominator is a 0, that's the possible location of a vertical asymptote. So let's take a look at here the basic functions. Some we are going to reuse this rational function again in topic 3, but here we are just looking at the understanding. Here is find the horizontal vertical asymptote of this function. So clearly we can see that whenever the denominator is 0, function will have a vertical asymptote. So that's the easy part, vertical asymptote at always you have to write it proper way. X is equal to 0. Never write vertical asymptote at 0. You have to write the equation of a line. Equation of a line has an equal to sign, and on the both side vertical asymptote at x equal to 0. Let's take a look at the parallel here also. We can see that the denominator, whenever denominator becomes 0, function will be undefined. That means there is a vertical asymptote at x equal to 1 and negative 2. If you need help, you can put it, set it equal to 0 and find. So there are two vertical asymptotes. One is at x equal to 1, another is at x equal to negative 2. So vertical asymptote was easy. All you had to look at the denominator. Now, horizontal asymptote. Horizontal asymptote occurs when x becomes very, very large. So here you have to see that x becomes very, very large. You don't have to worry about the 1. So very, very large number, million, trillion, think of that way. Subtract 1 and you divide by same number. Same number. So what happened? How do you simplify this? Very, very large number. 1 is not very important. And the ratio of the two same number is 1. So here you can say that horizontal asymptote is always a horizontal line. That means y equal to 1. You can also see that x over x is 1. When the degree is the same, this very, very large number, and the both ratio of the same number is a 1. That's why horizontal asymptote at 1. So let's take a look at here. In this case, x is a very, very large number. And then you are subtracting the same large number minus 1 and then adding 2. So in this case, this is practically x over, there are two x squares, right? I mean, two x's. If you FOIL it, x over x square and plus x minus 2, you can say that. So here you can see x over x square. And this considered as a denominator is going to be very, very big. So horizontal asymptote at y equal to 0. What y equal to 0 is x over x square is basically 1 over x. And we know that 1 over x has a horizontal asymptote at 0 because this is becoming bottom heavy function. We will talk about this again in a rational function unit, but at this time you should know that this is a bottom heavy function, or x over x square becomes 1 over x. Because x is very, very large, you just don't need, ignore all other numbers, you only look at the leading term. And 1 over x has a horizontal asymptote at 0, so that's why this function has a horizontal asymptote at y equal to 0. Let's take a look at a couple of more examples here. Okay, so this is a log function. You know that the log functions always looks like this is the basic log function. And x minus 2, that means 2 units to the right. And in this case, there is a vertical asymptote at x is equal to 2. Because the parent function has a vertical asymptote at x equal to 0, so this is moved to 2 units and there are no horizontal asymptote. Log function never have a horizontal asymptote. Know that log of negative number is not defined. So I'm just little going on the side track that domain is always x minus 2 greater than 0, which means x is greater than 2. That means there is a vertical asymptote at x equal to 2. E to the x plus 2. No, we know that e to the x have a horizontal asymptote at x equal y equal to 0. But this is a 2 units up. So that means no vertical asymptote, but horizontal asymptote at y equal to 2 because this function is shifted 2 units up. Okay, this is a polynomial. Polynomials do not have any asymptote because they are good guys. always defined at all real numbers. Domain is all real numbers. They are increasing forever, decreasing forever, and they do not have any asymptotes. So, one more time, asymptotes are very important. This is a very basic lesson. Again, we are going to look at the slant asymptote in topic 3, but this one is a very, very basic lesson on asymptotes.